Warm greetings. I'm Sharmila. I'm going to handle the subject digital signal processing. Today we are going to see about the introduction to digital signal processing. The main objective of this subject is to understand the basics of digital signal processing and to know about the basic elementary signals and their mathematical functions with some specified examples. Before that, we could see about the what is signal processing, what is digital signal processing, and what is signal. So signal is nothing but it conveys some message to one person to other person or one place to another place, or it carries the information from one place to another place. So it is defined as any physical phenomenon that carries or convey information from one place to other place, and it will be represented as a function of some independent variables such as time, distance, etc. Now you should see about this picture. It shows some fire and smoke, and one person is sending some message through smoke. And the next one is an audio signal, and the third one is it is nothing but ECG signal. It is the electrocardiogram signal. This signal represents or gives the information about the person's heart related activities. And now we see about some examples of signals. So we should know about the speech signals, audio signals, and video signals, EEG signals. EEG is nothing but electroencephalogram signal. It gives the brain activity of some persons. And the last one is ECG. And now we have about types of signals. These types of signals are classified into three types. The one is analog signal and discrete time signal and digital signal. So analog signal is a continuous time signal. It is represented as X and Y axis. In X axis it is represented as a time t, and Y axis it is a X of t. It is nothing but the voltage value or the magnitude value. And the discrete time signal is represented as a samples. The x-axis is represented as a t and y-axis is x of t. And the digital signals are represented as a zeros and ones. And next we see about the signal processing. Normally the signal processing are classified into many types. And what is signal? It is represented as a series operation performed according to the programmed instructions or some specified rules. Though signal processing is nothing but it is the processing of the signal involves the filtering the noise or interference from the desired signals. The signal processing can be classified into two types. The one is analog signal processing and another one is a digital signal processing. Now we see about the digital signal processing. I think you students should know about what is meant by digital. So it is the information or data is represented in zeros and ones. And we should know about the signal. It is carries information from one place to another place. So processing is nothing but a series of operations performed according to some programmed instructions. So combining these three, we can get the digital signal processing. Now you should see about the one example, that is MP3 audio player. In this example, the input has analog signal. This analog signal is passed to A to D converter, that is analog to digital converter. This analog signal is converted into digital signal like zeros and ones. And this signal is passed to digital signal processor. From here, we can eliminate the unwanted signals, that is noise, and this output is stored in the memory. If we want to play back the music means, then this data is retrieved from the memory through DSP or digital signal processor. Then it will be converted into analog signal using digital to analog converter, that is DAC, then we can get the output. Again, it is an analog signal. And there is also one example of public addressing system, that is a digital system. So the input is analog signal. Thus, through microphone, we can get the analog signal. This is converted into A to D. That the output of the ADC is digital signal. Say then some digital signal processing has occurred here. From this, we can get the digital signal as output. The input of the DAC is a digital, and then it will be converted into analog signal. Then finally, we can get the normal analog signal. So from this input, we can get the signals like this form, that is x-axis is time and the y-axis is voltage or amplitude. From this digital signals, that is converted into zeros and ones, and then finally we can get the VDAC, that is discrete time signal, that some noises are available. So this signal is again passed to filters. From this we can get the smoothened waveform. Now we see about the advantages of digital signal processing. So from this picture, what you can learn? So this picture shows the accuracy of the pointer, and the next picture shows the flexibility of the material, and the third one is the data storage device. So from this, we should know about the main advantages of digital signal processing, as it gives the greater accuracy of the data, and it is easy to flexible, and it is easy to storage data, and it also less expensive. And next we see about some applications of digital signal processing. The applications of digital signal processing is tremendous applications available. So this one is the radar application. So this radar and sonar is used to find out the distance of the particular object in some places. And so many applications are available, that is speech and music, in biomedical applications, graphics and imaging, consumer applications, industrial applications, telecommunication, and etc. This is the part of evaluation. I think you should know about this matching part. Thank you.